Hello, good evening students. Welcome to IMS GATE Academy. I hope you are enjoying the sessions on quick revision through formulas. I have given the lecture on geotechnical in the previous session. Now today I am here to explain you the quick revision through formulas for RCC, that is reinforced cement concrete. Students, this session is the intention here is to make a short note so that you can quickly revise the things. You can quickly revise the formulas and all. Now, what is the weightage of RCC, reinforced cement concrete? What is the weightage of the marks in GATE is? It is around 4 marks, students. Good evening, everyone. Good evening, Chandu. Good evening, Saurav sir. So here, what I would like to tell you here is, in RCC, we can expect 4 marks, and mostly the 4 marks, 2 marks is from pre-stressed concrete, and it will be fine, Chandu, fine. Actually, most of the 2 marks questions are from pre-stressed concrete, and it can be either from loss or from design. And coming to RCC, the 2 marks can be from the IS code specifications, Indian Standard Code specifications, or it can be from the beams. So we will concentrate more on the weightage of the marks on which topics they are covering. But in this session, within this time, stipulated time, I would like to cover all the formulas which are very important chapter by chapter. I hope you are enjoying the sessions of IMS GATE Academy for quick revision through formulas. We have extraordinary team for civil engineering. So please watch these videos, and if these videos are really helpful for you, you can share these videos and like, and you can share this. Now coming to the today's topic, we are going to discuss about is the reinforced cement concrete. What actually is reinforced? According to the Oxford Dictionary, reinforced means it is nothing but make it stronger. So why do they use steel and concrete in RCC? Why not other materials? The reason for steel and concrete in RCC is the coefficient of thermal expansion of both the materials is almost same. And moreover, my dear students, when we start RCC, there was a frequent questions asked by the people, like what exactly is the difference between analysis and design? Design is nothing but dimensions. Analysis is finding the calculation of shear force, bending moment, as well as the load calculations. So this is very important when you are learning about the RCC. So my dear students, I'll quickly go into the concepts without losing any time. So here I would like to tell you about the LSM. What exactly is LSM? LSM is defined as the limit state method. So what do you do? Previously, students used to work on working stress method. How limit state method is well appreciated by the designers. So limit state method is a method of designing a structures based on statistical concept of safety and probability of failure. So here when you design a structure, you should take care of safety, which is the very important parameter for a design engineer or for a civil engineer. So we take care of the safety as well as we take care of the statistics, means where it is going to fail. Or in simple words, what do you mean by limit state method? It is the ultimate stage at which the structure is unfit for use. It is the ultimate stage at which the structure is unfit for use. Remember, my dear students, whenever you are using limit state method, why it is most appreciated? In limit state method, if you take a design load is taken as load multiplied by partial safety factor. Similarly, if I take the design strength, you will take strength divided by partial safety factor. So here what do you mean by FD? FD is known as, capital FD is known as design load. Capital FD is known as design load. And here, my dear students, here this is known as design strength. Here it is known as what, my dear students? Design strength. So when you are designing for higher loads, because you are multiplying with the load with a partial safety factor. So you are designing for higher loads. You are designing for higher loads, and at the same time, you are designing for lesser strength. So these are very important, not only for GATE exam. When you attend any campus interview in the topmost multinational companies, this is the common question they ask for RCC. Why LSM method is most appreciated? As LSM method is designing for higher loads and lesser strength, you have to ensure. So these two things is making LSM a double safety. So you are giving the structure double safety. So that is the reason LSM method is most appreciated. I hope you are clear. What do you mean by limit state method? Limit state method is a method of designing a structure based on statistical concept of safety and a probability of failure. In limit state method, we are going to design for higher loads and lesser strength. This is the reason why limit state method is most appreciated. Okay. Now, my dear students, I would like to tell you one important thing. What is the thing here is, in limit state method, we have another two things. One is the limit state of collapse and other one is the limit state of serviceability. So, in limit state of collapse, we discuss about the failure. Suppose, my dear students, we have different structural elements like a slab, beam, column, footing. All these are called structural elements. When these structural elements are connected together, it forms a structure. So when I talk about limit state of collapse, which comes under limit state of collapse? Flexure, that is nothing but bending. Shear, that is called tangential force, or compression and torsion. So flexure, shear, compression, torsion comes under limit state of collapse. Similarly, in limit state method, my dear students, we have the limit state of serviceability. So what actually limit state of serviceability will talk about is, serviceability will talk about the age of the structure. It talks about the age of the structure. So in limit state of serviceability, we come across deflection, cracking, vibration and settlement. So what comes under serviceability? Deflection, cracking, vibration and settlement, my dear students. So why sir is explaining the concept here? Because this was one of the previous GATE question. Which of the following is a limit state of collapse? So flexure, shear, compression, torsion or comes under limit state of collapse, and deflection, cracking, vibration and settlement will come under limit state of serviceability. Very good, my dear student. Now we have a very important question. So my dear students, when I talk about the partial safety factor for steel, the partial safety factor for steel is 1.5. Similarly, the partial safety factor for concrete is how much, my dear students? It is nothing but 1.5. This was a famous question asked in one of the interviews also. Why the partial safety factor of concrete is more? Why it is more compared to the partial safety factor of steel? Why the partial safety factor of concrete is more when compared to steel? Can anyone answer me? The reason is concrete is manufactured in the laboratory, whereas steel is manufactured in the industry. So the reason here is, my dear students, quality control. So quality control is the reason why the partial safety factor of concrete is more when compared to steel. I hope you are clear. So this is one of the important things you should be clear. Next. Now see students, actually when we talk about the limit state of limit state of collapse, first we'll talk about the singly reinforced section. Now what exactly do you mean by singly reinforced section? So what exactly do you mean by singly reinforced section? So here, when I talk about the singly reinforced section, my dear student, what exactly is singly reinforced section, my dear students? So here singly reinforced section is nothing but a beam which is reinforced on tension side is known as singly reinforced section. A beam which is reinforced on tension side is known as singly reinforced section. So this is how the strain variation will be there. And if I consider this as the neutral axis, this is how the stress distribution will be there. This is how the stress distribution. So the common question everyone asks me is, good evening Guru, the common question everyone asks me here is, how is the stress strain curve for concrete? The stress strain curve for concrete is rectangular parabolic, and the strain distribution for singly reinforced concrete is taken as linear distribution. So see students, what is the maximum value of strain in compression is 0.0035, and what is the strain value in tension? If we see, the strain is 0.87 Fy upon Es plus 0.002, and this is called as XU, which is known as the depth of the neutral axis. And here we have a graph, this is equal to 0.002. Now my dear students, we have a tension force here, that is 0.87 Fy AST, and we have a compression force here, that is equal to 0.36 FCK B into XU. Here we have the thing is, here we have a value called compression force, compression stress is equal to 0.446 FCK. So these are the values. Good evening Ajay, good evening. So these are the values you have to remember, my dear students. So this is the maximum value of strain in tension, and this is the maximum value of strain in compression. This is the compression force, and this is the tension force. Okay. So if you ask me how is the strain distribution is, the strain distribution varies linearly and the stress distribution varies rectangular parabolic. So here my dear students, when I talk about the important formulas, the first and the foremost, very, very important, the compression force is given by the formula 0.36 FCK into B into XU. So if you ask me how to remember this formula, you can remember this is the stress and this is the area. Stress into area is nothing but the force. What is B? B is nothing but the width of the neutral axis. XU is the depth of neutral axis. Sorry, B is the width of the section. XU is the depth of neutral axis. FCK is the grade of concrete or characteristic strength of concrete. When I talk about the tension force, tension force is given by the formula 0.87 Fy AST. What is Fy? Yield stress of steel. AST is the area of the steel. Now my dear students, how do you calculate the depth of the neutral axis? The depth of the neutral axis is given by the formula or is calculated. We assume the section to be balanced. We have three types of sections. I will explain you later. So here, how do you rate the formula for depth of neutral axis? So the depth of the neutral axis is given by the formula 0.87 Fy AST upon 0.36 FCKB. So this is the formula to find out the depth of neutral axis. So how do you assume the depth? How do you calculate the depth of the neutral axis is? We calculate the depth of the neutral axis by assuming the section to be balanced. So I hope you are clear with this, my dear students. Now coming to the next one, I would like to talk here is the moment. Next one I would like to talk here is the moment. So what exactly is moment? Moment can be taken as compression force into lever arm, or it can be taken as tension force into lever arm. So moment can be calculated either compression force into lever arm or tension force into lever arm. Is this clear, my dear students? So moment can be taken as compression force is equal to 0.36 FCK B into XU. And what is the value of lever arm? Lever arm is taken as D minus 0.42 XU. So here, my dear students, what exactly is lever arm is? Lever arm is the distance between the point of application of compressive force and tension force. If you see the stress distribution diagram, I have shown you like this. And here the compression force acts, here the tension force acts. The distance between these 2 points of applications is defined as lever arm. Any doubt, my dear students? So what exactly is lever arm? Lever arm is the distance between the point of application of compression force and tension force. So my dear students, this is the formula to calculate the moment. Similarly, my dear students, if you have taken tension force, the formula is given as 0.87 Fy AST into D minus 0.42 XU. My dear students, don't forget the underlying concept. What is the formula for moment? Moment is defined as the force into, what is moment? Thank you, Ganesh. So what do you mean by moment? Moment is defined as the formula as force into displacement. So here, what is the force? Here the force is nothing but the tension force. What is D minus 0.42 XU? It is nothing but lever arm. So whenever you are writing the GATE exam, my dear students, these formulas are very important. So don't forget the underlying concept. If your underlying concept is clear, there is nothing here. It is nothing but force into displacement. You can adopt a tension force or you can adopt the compression force. So here I have a small question for you, my dear students. Sir, see, my dear students, there was a graph for the stress strain curve for concrete. What is the graph for the stress strain curve of concrete? So here, when I talk about the stress strain curve for concrete, it is rectangular parabolic. What is the stress strain curve for concrete? The rectangular parabolic. This is a very important. So here, what is this? So here, my dear students, this is the common question I will ask you every time. Okay. So when you draw the stress strain curve graph, this is the common question. Why do you write strain on x-axis and why do you write stress on y-axis? This is the common question. We are talking about the stress strain curve for concrete. This is for which diagram? This is not for steel, my dear students. That's the stress strain curve for concrete. When I talk about the stress strain curve for concrete, okay, you have to remember that, my dear students. Good evening, Nikhil sir. Good evening. So here what I would like to tell you here is, when you are writing something on x-axis, it is the known quantity. And the dependent quantity on the x-axis, there will be some dependent thing that will be written on y-axis. So known quantity usually we take on, or independent quantity will be taken on x-axis and dependent quantity will be taken on y-axis. So if anyone asks you what is the stress strain curve for concrete, the stress strain curve for concrete is rectangular parabolic. This is an objective question and a very common question in so many competitive exams. So the stress strain curve for concrete is rectangular parabolic. So what is the values up to parabola? What is the value here is, it is taken as 0.002. And what is the value here at the extreme is, it is taken as 0.0035. That is the reason the maximum strain in concrete. Please write down this point, my dear students. The maximum, Rohit Rai, very good Rohit Rai. The maximum strain in concrete is taken as 0.0035. Now I have a question for you. What is the stress here? The stress here is taken as 0.67 FCK. But if you see the diagram, I have shown you the value as 0.446 FCK. So you can ask me, sir, why? Actually, how this 0.67 FCK came? Remember, my dear students, actually you can remember that FCK was reduced to 0.67 FCK either due to slenderness ratio or due to shape effect. Are you getting me, my dear student? This is a very important clause. The reduced strength. Why the strength has been reduced from FCK to 0.67 FCK is the question, the concept behind is either due to shape effect. Suppose if you are taking a concrete cube, you will cast the concrete cube in a cube, or sometimes it can be a cylinder, or sometimes it can be any shape. Due to the shape, we are reducing from FCK to 0.67. Then how this 0.446 FCK came? So here, my dear students, you remember that design strength is equal to 0.67 FCK. And what is the partial safety factor for concrete? Can you quickly answer me? Very good, Rohit. So it is taken as 1.5 and this will be equal to 0.446 FCK. So I would conclude 3 points from this graph. The question here is the stress strain curve for concrete is rectangular parabolic. The strain value at parabola is 0.002. The maximum stress strain in concrete is 0.0035. The stress at the level of parabola is 0.67, or the maximum stress in concrete is 0.446 FCK. Now, this point is important, my dear student. Actually, what is the code book used in what is the code book used? They can ask you, my dear students. The code book used for RCC is IS 456. Here, what I would like to tell you is, I have drawn this graph right here in this portion. This is a clause from the IS code. Like what does the IS code says is, it need not be parabola. It can be any shape. But don't, when they ask you what is the stress strain curve for concrete means, you have to write rectangular parabolic. But to go more in detail, according to the IS code, it need not be parabola. It can be any shape, but the test results should be satisfied. But what should be satisfied? But the test results should be satisfied. Very good answer, Adari Ganesh. Very good answer. Very good answer. So here, similarly, when I talk about the stress strain curve for steel, then we will talk about the stress strain curve for steel. We will talk about the stress strain curve for steel. So what do you mean by the stress strain curve for steel? So here, when I talk about the stress strain curve for steel, as I told you, the stress strain curve for steel will be like this. Now, here the stress value will be 0.87 Fy. This is stress, and here this value will be equal to 0.002, and this is the strain. Now, they can ask you, what is the maximum strain in steel? So here, remember, my dear students, the maximum strain in steel, from here to here, what is the value? From here to here, it is 0.002. Okay, so we have to find out this. Actually, Young's modulus can be taken as stress upon strain. From this, what you will write strain? Strain will be equal to stress upon Young's modulus. Now, this portion will be equal to 0.87 Fy upon Es. So, if anyone asks you, what is the max? Okay. The Rohit Rai depends upon carbon content percentage. Actually, very good. See, the strength of the steel depends upon, means actually as carbon content increases, Rohit, as carbon content increases, the strength of the steel increases, but there is a disadvantage also. At the same time, the brittleness also increases, ductility reduces. Okay, that is also another important. So the maximum strain in steel is taken as the formula 0.87 Fy by Es plus 0.002. So if anyone asks you what is the maximum strain in steel, the maximum strain in steel is taken as 0.87 Fy upon Es plus 0.02. That is the formula for the maximum strain in steel. I hope You are clear. Now see students, when I talk about the types of the section, when I talk about the type of sections, we have different types of sections in RCC. Okay, this is a generalized thing. There is nothing to do with the formulas. See, my dear students, we have different types of sections, like one is balanced section and other one is under reinforced section, and next one we have is the over reinforced section. One is under reinforced section and the next one we have is the over reinforced section. So what are the different types of sections we are having? We are having three types of sections. One is balanced section, under reinforced section, as well as over reinforced section. So here, my dear students, try to understand individually what is a balanced section. So see, practically balanced section is impossible. So the amount, see, what do you mean by balanced section means the stresses in steel and concrete, the stresses in steel and concrete reaches the, very good answer Ganesh, the stresses in steel and concrete reaches the maximum value at the same time, then it is called balanced section. Then it is called balanced section. Now, what is the question in asked in GATE is, what is the primary failure? Means, sorry, what is the primary cause for failure in balanced section? The primary cause for failure in balanced section is, you can write here, primary compression. I will tell you. So here, primary compression is the thing which is used, means the failure, sorry students, how the balanced section is supposed to fail is primarily by compression. For under reinforced section, primarily by what you can say, tension. And when do you say that over reinforced is compression? So my dear students, Ganesh has answered one of the beautiful answers. For your information, I totally agree, my dear students. A balanced section, under reinforced section and over reinforced section, let me do this way. See how much amount of steel is provided. Here the condition for balanced section is XC is equal to XU max or AST is equal to limiting area of steel. Are you getting, my dear students? When these conditions are satisfied, then it is a balanced section. In under reinforced section, XU will be less than XU max, or you can say AST is less than AST limiting. Similarly, my dear students, if I talk about over reinforced, XU is greater than XU max, or you can write AST is greater than AST limiting. So actually, when you talk about GATE problems, it is not about only finding the conditions. So let us understand. Very good answers, Amma. Very good answers. When you talk about a balanced section, here the maximum stresses in steel and concrete reaches the maximum value at same time. But remember, practically it is impossible to have a balanced section. Then why are you studying balanced section? Is to find the depth of the neutral axis, we assume the section to be balanced. The next thing I will ask you, when do you say that a section is under reinforced? The name itself under reinforced. When India is playing cricket with Zimbabwe, Zimbabwe is treated as underrated. What do you mean by underrated? The amount of steel required to provide for balancing will be less. So how much steel is required to balance, that much steel you will not provide. You will provide lesser steel. When you are telling that the steel is less, obviously the failure will be in steel. So as steel is a ductile material, it clearly shows a sign of warning. Or as steel is a ductile material, it clearly shows a sign of warning. That is the reason most of the practically all the sections are under reinforced. But similarly, what is over reinforced? The name itself over reinforced means the amount of steel provided is more than the amount of steel required. When you are providing more steel means you are reducing the concrete. So the failure will be in concrete and concrete will fail by compression. So concrete is a brittle material. The failure will be sudden because as I told you, limit state method, safety is taken as the highest priority. So in that case, practically all the over reinforced sections are avoided. Is it clear, my dear students? So let me conclude this thing. We have three types of sections: balanced section, under reinforced section, and over reinforced. Practically all the sections are designed as under reinforced, as the amount of steel required to, as the amount of steel provided is less than the steel required, amount of steel provided is less than the maximum area of steel or limiting area of steel. So the failure is in steel. Steel is a ductile material, so it shows a clear sign of warning. But when we talk about balanced section, the maximum stresses in steel and concrete reaches the maximum value at same time. But we cannot expect any section to be balanced practically. But why do you want to study about balanced section is, you are studying to find out the depth of the neutral axis. In over reinforced, the amount of steel provided is more, so the amount of concrete will be less. As concrete is a brittle material, you can understand that the failure will be in concrete, and practically as the failure is in concrete, the failure will be sudden. So practically you have to avoid this over reinforced section. So this is what actually you have to study about the under reinforced, over reinforced and balance. In GATE point of view, my dear students, based on this question, there was a GATE question on 2020, and also they can ask you balanced failure mainly by primary compression, under reinforced by primary tension, and over reinforced by compression. Why? Because over reinforced failure is in concrete, concrete failed by compression, and the failure is in steel, steel failed by tension. But in balanced, the amount of concrete is always huge when compared to the amount of steel. So the failure will be in concrete. So the answer will be compression. Now see students, this is a very important table. So when I take Fe250, Fe250 is considered as mild steel and different grades of steel. Fe415 is considered as HYSD bars, or you can write it as high yield strength deformed bars. When I talk about Fe250, Fe415 or Fe500, you can write here XU max by D value. XU max by D value will be considered as here 0.53, 0.48, and here it is equal to 0.46. So this table is very, very important. Apart from this, you can also take it as MU limit. Limiting moment of resistance is given by the formula 0.149 FCK BD square, 0.149 FCK BD square, or 0.138 FCK BD square, or you can say here 0.133 FCK BD square. So here there was a famous question, my dear students. XU max by D depends only on the grade of the steel. So they can ask you, it depends only on what? XU max by D actually depends only on, or depend only on grade of steel, or you can say yield stress of steel on grade of steel only. Because how this formula is being adopted is by the strain distribution curve, you will derive this formula. Is it clear? Now, how do you calculate MU limit? How do you calculate MU limit is, see here when I talk about the MU limit is the limiting moment of resistance. You know moment is equal to what, my dear students? Moment will be taken as 0.36 FCK B into XU into D minus 0.42 XU. So here what will happen is, here XU will be replaced by XU max. When XU is replaced by XU max, then M will also be replaced as limiting moment. Suppose if they give you grade of steel as Fe415, you replace XU max with 0.48D. So this is how you have to find out the limiting moment of resistance or XU max by D values. Is this clear, my dear students? Is this clear? Can you please quickly respond? So for Fe250, XU max by D is 0.53. For Fe415, it is 0.48. For Fe500, it is 0.46. And MU limit values, as the grade of the steel increases, the limiting moment of resistance is decreasing. So please keep a note of this. In problem solving, these will be helping you. Okay, because these are the common questions they have asked them in the previous gate questions. Now see students, the code used for RCC is IS 456. So here when I talk about effective span, so we have a concept called effective span. So what exactly do you mean by effective span? If I take a simply supported beam, what do you mean by simply supported beam? A beam which is supported on both the ends is nothing but simply supported beam. So when I talk about the effective span, see my dear students, this is a simply supported beam. So what do you mean by, so here you can draw here, this is a simply supported beam. So actually when you talk here, so one is the center to center distance and this is called as clear span. This is called as clear span. So my dear students, the effective span of simply supported beam is given by the formula, clear span plus D, is given by the formula clear span plus D. And the next one we have is the center to center distance between beams. Center to center distance between supports, not beams. Center to center distance between supports. So out of these two, which value will be taking as effective span? Whatever the value which is smaller, will be taken as the effective span. How do you know these values is? These values are known from the code. Very good answer, Ganesh, very good. So the minimum value of clear span plus D or the center to center distance between the supports, out of these two values, the minimum value will be taken as the effective span of simply supported beam. Is it clear, my dear students? Is it clear? Now similarly, my dear students, when I talk about a cantilever beam, what is a cantilever beam is a beam which is fixed at one end is known as a cantilever beam. In this case, the effective span is given by the formula, clear span plus D by 2. There is no other formula, means there is only one formula. There are no two formulas here. The effective span for cantilever beam is given as clear span plus D by 2. This is the formula for which beam? A cantilever beam. Remember what is a cantilever beam? A beam which is fixed at one end is known as a cantilever beam. Next. Now my dear students, when I talk about the minimum tension reinforcement, they can ask you what is the formula for minimum tension reinforcement. The minimum tension reinforcement is given by the formula AST by BD is equal to 0.85 upon Fy. What is AST? Area of the steel. What is BND? The cross section details of the section. What is Fy is? Fy is known as the yield stress of steel. So the minimum tension reinforcement is given by the formula AST by BD is equal to 0.85 by Fy. Or they can ask you what is the maximum tension reinforcement. The maximum tension reinforcement is given as 4 percentile of gross area. That is equal to 0.04 BD. That will be equal to how much, students? That will be equal to 0.04 BD. BD. See students, if you write small d, here it is B capital D. That is very important because it is gross area. Similarly, my dear students, when you talk about the when you talk about bond or clear cover, what do you mean by clear cover and what do you mean by effective cover? This is also another important thing, student, because there was a previous gate question. Suppose if we consider a steel here, now see students, anyhow this is called effective depth, okay, and this is called the width of the section and this is the overall depth of the section. Am I clear, my dear students? The distance from the centroid of the steel to the extreme fiber is known as effective cover. Is known as what, my dear students? Is known as the effective cover. What is effective cover? The distance from the centroid of the steel bar to the extreme fiber is known as the effective cover. Suppose if you have a stirrup also, the distance from the extreme, So here you can write here the distance from the outermost of the steel. If there is stirrup also, this is a previous gate question, please write a note of it, because some people will not include the stirrup. Even though there is a stirrup here, if you have a stirrup here, you should understand that there is a stirrup here. From the outer edge of the stirrup, you have to consider to the extreme fiber. This will be equal to the clear cover. So I hope you are clear about cover and effective cover. Effective cover is the distance from the centroid of the steel to the extreme fiber, and it is the outermost of the steel proportion. Even though it is there, stirrup is there, from the outermost of the stirrup to the extreme fiber. Now you can ask me, why do people provide cover? Cover is provided to have a proper bond between concrete and steel. To have a proper bond between concrete and steel, this cover is provided. And see, my dear students, if you consider sea coast or in marine exposure, the cover should be more, because it will be considered as the most severe condition. That is because in sea condition, you will have efflorescence or alkali nature, then there are more chances of rusting. In these cases, clear cover and effective cover should be more, rather than normal things you have to provide more than the normal, because in those cases that affect the rust of the iron. And remember, my dear students, we also provide side face reinforcement. So usually side face reinforcement is provided when depth of the beam exceeds 750 mm, side face reinforcement is provided. And how much it will be provided is 0.1 percentile of web area. 0.1 percentile of web area is provided, and this will be distributed on both the faces. It will be distributed on both the faces. Is it clear? So my dear students, just give me a second. I will completely revise the important topics of LSM, and in this slide, my dear students, I will cover all the formulas. If you have time, take the screenshot also that. Now see, students, now the first formula is finding out the depth of neutral axis. So XU is equal to 0.87 Fy AST upon 0.36 FCKB. So what is XU? XU is known as depth of the neutral axis. Next, similarly, what do you mean by compression force? Compression force is taken as 0.36 FCK B into XU. What is CF means? Compression force. What do you mean by TF? Tension force. Tension force is taken as 0.Fy AST into D minus 0.42, sorry. 1 second, students. So 0.57 AST. Now what do you mean by moment? Moment is equal to tension force into lever arm, or it can be compression force into lever arm. So you can write tension force into lever arm or compression force into lever arm. What is lever arm? It is the distance between compression force and tension force. So here you can write it as 0.36 FCK B into XU into D minus 0.42 XU. D minus 0.42 XU is the lever arm, you can write here. Or you can write 0.87 Fy AST into D minus 0.42 XU. So this is the formula for what, my dear students? For the moment. Similarly, for FE 250 grade, or for FE 415 grade, or for FE 500 grade. So, okay. So, what is the XU max values? As I have written, XU max by D. So, I want to cover everything in one slide. Or when you say MU limit. So, what is the values, my dear students? The values are 0.53, 0.48, 0.46. And what will be the moment limit equations? 0.149 FCK BD square, okay, 0.138 FCK BD square, or 0.133 FCK BD square. So here I would like to tell you one more important thing, the maximum strain in concrete. What is the maximum strain in concrete, my dear students? The maximum strain in concrete is, you can write it as 0.0035. It is equal to 0.0035. maximum strain in steel, maximum strain or maximum strain in steel is 0.87 Fy by ES plus 0.002. Okay, minimum tension reinforcement is equal to AST by BD is equal to 0.85 by Fy. This is the formula for minimum tension reinforcement. Next thing what you can also understand is, you also have to write here, 1 second students, you also have to write when the section is under reinforced, XU is less than XU max and AST is less than AST limiting. So I want to cover everything in one slide. That is the reason. If it is over reinforced students, over reinforced is XU greater than XU max or AST greater than AST limiting. So if you can remember these formulas, most of the questions from this chapter will be calculated. Is it clear for everyone? Is it clear, my dear students? Can you quickly respond? Is it clear? Take a screenshot of this so that it will help you. Okay. Next, my dear students. Now, when I talk about the basic or fundamental concepts, see here, when I talk about the fundamental concepts, the first and the foremost thing is, we'll talk about the characteristic strength. The first and the foremost thing we have to talk is the characteristic strength. What do you mean by characteristic strength of concrete? Anyone, can you explain me what do you mean by characteristic strength? Characteristic strength is defined as the strength at which 95% of the test results are satisfied and only 5% of the test results are expected to fall. So what is characteristic strength? It is the strength at which, characteristic strength is defined as the strength at which, 95% of the test results are expected to pass. It is the strength at which 95% of the test results are expected to pass, or not more than 5% of the test results are failed. That is known as characteristic strength. Or you can write here, my dear students, there is a formula also. Target mean strength is equal to characteristic strength plus constant, we can say 0.65 into S, that is standard deviation. So target mean strength is given as FCK plus KS. So here what is the previous gate question is, if characteristic strength is defined as the strength at which 50%, see they have given the definition and they are asking what is target. So actually see students, when I tell you 95% probability curve, here only 5% it is failing. But in the question he has given that 50% of the test results are expected to fail or expected to pass. Then in that case, this is known as standard deviation. Now if it is 50% means this line will become here. In that case, standard deviation will be 0. So target mean strength will be equal to FCK. So what I would like to tell you is, what is standard deviation is, thank you Nikhil. So here what do you mean by characteristic strength is, it is the strength of the concrete at which 95% of the test results are expected to pass, or it is that strength at which not more than 5% of the test results are expected to fail. Target mean strength is given as FCK plus K into S. Here in previous gate question is, if characteristic strength is defined as the strength at which 50% of the test results are expected to fail or pass, in that case target mean strength will be equal to the characteristic strength. And here usually when you do the testing of concrete, you will take 3 cubes and you will do the average of these cubes. So when you take the 3 cubes, their individual variation should not be more than plus or minus 15%. The individual variation should not be more than plus or minus 15%. And remember, my dear students, usually 3 cubes are taken into consideration for the testing of the concrete. So if anyone asks you how to find out the standard deviation, you already know you have to calculate the individual strength minus mean, okay, upon n minus 1, okay, this whole square into sigma square root. Anywhere, wherever you find standard deviation, this is the quite common formula, f minus fi into, 1 second, student, whole square upon n minus 1 into square root. So this is the standard deviation. Wherever you go, this is the static formula. Now, my dear students, the another important thing I would like to talk you about here is the short-term modulus of elasticity. The short-term modulus of elasticity is given by the formula 5000 root FCK. Very important formula. The short-term modulus of elasticity is given by the formula 5000 root FCK. And similarly, the long-term modulus of elasticity is given as short-term modulus of elasticity upon 1 plus theta, where theta is known as the creep coefficient. What do you mean by creep? It is defined as the long-term deflection under constant loads. So here theta is taken as creep coefficient. The creep coefficient value for 7 days it is 2.2. Like for 1 month it is very good, Rohit, very good. It can be taken as short 5000 root FCK upon 1 plus theta. Theta is known as what, my dear students? Theta is known as creep coefficient. What is creep coefficient can be defined as ultimate creep by, theta can be written as creep coefficient can be taken as ultimate creep upon elastic creep. So there was a previous GATE question on this formula also. Long-term modulus of elasticity is given as short-term modulus of elasticity upon 1 plus theta. And another important formula you can also ask here is, the thing is, what is the flexural strength of the concrete? The flexural strength of the concrete is given by the formula, or split tensile strength of the concrete is given by the formula 0.7 root FCK. So please remember these formulas. The short-term modulus of elasticity is given as 5000 root FCK. Long-term modulus of elasticity is given by short-term modulus of elasticity upon 1 plus theta. And creep coefficient is given as theta is equal to ultimate creep upon elastic creep. And the flexural strength is given by the formula 0.7 root FCK. So these are the basic formulas. And when I talk about the doubly reinforced section, so see students, when I talk about doubly reinforced section, what do you mean by, when do you say that when do you go with doubly reinforced section? So see, actually if the depth of the beam is more, or if you want to follow a more, in case if you want to provide a more depth, so to limit the depth or to reduce the depth of the beam, we go with the doubly reinforced section. Or for architectural purpose, or when a beam is subjected to some stress reversal or impact loads or vibration loading, then we go with doubly reinforced section. And remember, doubly reinforced is not a over reinforced section. Here the amount of steel will be distributed on both the sides. So what is a doubly reinforced section here is a beam which is reinforced on tension side is known as singly reinforced. A beam which is reinforced on both the tension side as well as compression side. A beam which is reinforced on both the tension and the compression side. Both tension and compression side is known as doubly reinforced section. And now, my dear students, I would like to tell you here very important thing, Amma. Here, two things you have to take. So the beam looks like this. If you take the beam here, there will be a steel in the compression side as well as there will be a steel in the tension side. So this is how what exactly is doubly reinforced section. So whenever you find the depth of the neutral axis, here you should understand that there are two things. One is what you can say compression force. Compression force will be due to steel as well as concrete. Usually in singly reinforced, compression force will be only due to what, my dear students? Only due to concrete. So here compression force can be taken as 0.36 FCK B into XU plus FSC minus FCC into ASC, area of steel in compression, is equal to 0.87 F by AST. So this is the formula which you have to remember for finding the depth of the neutral axis in case of doubly reinforced. This is the formula which you have to follow for in case of what, sir? In case of doubly reinforced section, which formula you have to follow? The formula you have to follow is this one. So this is the compression force. This is the compression force due to what? This is the compression force due to concrete. And C, due to and what is FSC? This is the stress in steel in compression. Stress in steel in compression. So here when I talk stress in steel in compression, but in problem students, FCC is very small, so sometimes they will write FSC into ASC also, because as FCC is very small, this formula can also be written as FSC into ASC. So when I talk about the moment equation, the moment equation for doubly reinforced section is given by this formula, 0.36 FCK B into XU max. Actually we should take XU max, limiting moment D minus 0.42 XU max plus FSC into ASC into D minus D dash. Actually, my dear students, FSC, if you take the stress in steel, FSC depends upon the ratio of D dash by D. Okay, based on this ratio, actually, the FSC will be depending. Now, my dear students, they can ask you one more thing. Here, see, they will provide you steel in compression and you will have cover here and here. So, what is D means? This one. Okay, what is D minus D dash means? This one. This is known as, D dash is known as effective cover on compression side, not on the tension side. What is D dash? D dash is the effective cover on which side? It is the effective cover on compression side. Is it clear, my dear students? Is this clear for everyone? Okay. So this is what about the doubly reinforced section. Now quickly we'll go across the concept called shear reinforcement. We'll talk about shear. Now my dear students, what do you mean by shear? A shear is nothing but a tangential force per tangential force. So whenever you are talking about shear, see students, what is the, see, for every structural element there is a design criteria. Usually when you design slab, we should assume that there should be no deflection. When you talk about a beam, we will avoid bending. When you talk about column, short column crushing, for long column you usually assume we should not buckle. For footing design, shear is important. Sir, this is the common and beautiful question from the interview point of view. Why the footing is taking care of shear? Actually, the depth of the foundation depends upon shear, my dear students. This is a very important point for you. The depth of the foundation depends upon what? The depth of the foundation depends upon the shear. This is a very, very important point I would like to add. So here when I talk about the shear, when you talk about the design, my dear students, I would like to tell you very, very simple things. So first thing we have is the tau v. Tau v we call it as nominal shear stress. What is tau v? Tau v is known as nominal shear stress. Okay, tau v is known as nominal shear stress and it is given by the formula tau v is equal to Vu upon Bd. So what is tau v? Tau v is known as Vu upon Bd, which is considered as nominal shear stress. Okay. Now similarly, we have tau c max is called as maximum permissible shear stress, and this tau c max depends only on grade of concrete. This tau c max depends only on grade of concrete. I'll tell you, sir, why. Actually, it depends only on grade of concrete. And tau c max is given by the formula 0.62 root FCK. Tau c max depends upon grade of concrete and it is given by the formula. You can write tau c max is equal to 0.62 root FCK. This is the formula for tau c max. Now, my dear students, when I talk about the nominal shear stress, the nominal shear stress, you should also talk about the varying section, which is very important. The nominal shear stress for varying section is given by this formula. VU plus or minus M by D tan beta upon BD. Okay, are you getting me? So here this is the formula for nominal shear stress. Okay, nominal shear stress in case of varying section. This is the formula for nominal shear stress in case of which section? In case of varying section. So see students, usually when we take a cantilever beam, the bending moment will be maximum at the fixed end. When the bending moment is maximum at the fixed end, what I would like to tell you is, as the depth is increasing, what is happening to the bending moment? The bending moment is keep on increasing. So in this case, you will use positive sign. And when do you use negative sign here is, remember my dear students, when the bending moment, suppose in case of a simply supported arch or anything. So here if you see, when the bending moment, see, as the depth is increasing, how is the bending moment? The bending moment will be like this, and here the bending moment will be like this, if you see. So the bending moment is minimum at supports. So here if you see, the depth is more, bending moment less. In this case, you will use negative sign, and in this case, you will use positive sign. Are you clear when to use positive sign and when to use negative sign? The nominal shear stress is given by the formula VU plus or minus M by D tan beta upon BD. When the moment is increasing with the increase in depth, then you will use positive sign. When the moment is decreasing with increase in depth, then you will use negative sign. This is how you tell the nominal shear stress. Now, my dear students, actually, when a beam or any section, if you take any section, when it is subjected to pure shear, what will happen? Either it will, there can be two chances. There can be two chances of failures, my dear students. So what are the two chances of failures? I will tell you. Either due to pure shear, what will happen, my dear students? Either there can be a diagonal tension failure, or there can be a diagonal compression failure. So there can be two types of failures. One is diagonal tension failure, or there can be a diagonal compression failure. So there can be two types of failures, my dear students. One is diagonal compression failure, or another one is diagonal tension failure. So how do you take care? Because these two should be avoided. How can you avoid this? So my dear students, diagonal tension failure is avoided by providing the steel. So by providing steel in the form of bent up bars, or you can say stirrups. Okay, when you take bent up bars or stirrups or inclined stirrups, this diagonal tension can be avoided. That is the reason. What is diagonal compression failure? Sir, see, my dear student, this is a very important. When you say that when your tau V, nominal shear stress, is greater than tau C max, then you have to redesign. Then what you have to do? You have to redesign the shear, means redesign for shear. So that why you are not allowing is tau C max is a check for diagonal compression. I repeat this point again. There can be two chances of failures. One is diagonal tension or diagonal compression. So diagonal tension failure, you will provide the steel and you will avoid it. But in diagonal compression, if it occurs, that is the biggest failure. So you will not allow the section to fail diagonally in compression side. So you have a check when tau V greater than tau C max, you will redesign the structure. Is it clear, my dear students? Is it clear? So here I will talk quickly about the design of the section. Okay, design of shear. See here, when I talk about the design, before moving to the design of the shear, I would like to tell you the important things. So here, when a beam is subjected to tension, the critical section will be at the face of the support. So, or you can say, when a beam is subjected to tension or in tension, the critical section will be at where? The critical section will be at the face of the support. Okay. Now, similarly, my dear students, when you consider a simply supported beam, the critical section will be at a distance, how much, sir? The critical section will be at a distance D. The critical section will be at a distance d. Are you getting me? So this is how you have to solve the problem. So the critical section will be at a face of the support in case of tension, and in compression it will be at a distance d. I hope you are clear. It will be more helpful if you do problem solving sessions. Definitely 21 or 2, I will definitely solve that. Actually, we already have solved the problems, my dear students. We have a session called Gate Square Booster. We have a session called Gate Score Booster series. In that you can go to the RCC and see there. I have already solved that session 20 days back, my dear students. Okay. You can observe there. Now see students, when I talk about the design of shear, when I talk about the design of shear here, please understand this carefully, my dear student, because we can expect a question from this chapter. Okay, either from the design of beams or design of shear you can expect. So here, when tau v is less than 0.5 tau c, there you have to write that no shear reinforcement is required. When tau v is less than 0.5 tau c, no shear reinforcement is required. Now, my dear students, I would like to tell you one more thing. Tau c depends upon percentage of steel, that is AST by BD into 100. What is percentage of steel is AST by BD into 100, and it also depends upon the grade of the concrete. Okay. Next, when tau v is less than tau c, when tau v is less than tau c, my dear students, you should understand that when tau v is less than tau c, you should go with minimum shear reinforcement. You should go with minimum shear reinforcement. The minimum shear reinforcement is given by the formula ASV into B into SV is equal to 0.4 upon 0.87 Fy. This is the formula for minimum shear reinforcement, and a very important formula. When tau v is less than tau c, we should design for minimum shear reinforcement. What is ASV? Area of vertical stirrups. What is Fy? Yield stress of steel. SV is known as vertical spacing and B is known as the width of the section. So here when they talk about when tau v is greater than tau c, so when tau v is greater than tau c, shear reinforcement is mandatory. You should say that shear reinforcement is mandatory. Shear reinforcement is mandatory. Okay. Here the design shear force is given by the formula tau v minus tau c into BD. So you have to provide how much the design shear force is given by the formula. Another formula is the design shear force by equating this also 0.87 Fy ASV into D upon SV. Okay. This is the formula for stirrup. So when tau v is greater than tau c, the design shear force is given by the formula 0.87 Fy ASV into D upon SV. Is it clear? So here what I would like to tell you, now these are the important formulas, my dear students. If they give you in case of inclined stirrups, means when the stirrups are inclined, the design shear force, in case of inclined stirrups, the design shear force is given by the formula, the design shear force is equal to 0.87 Fy A into SV into D upon SV. So is equal to sin alpha plus cos alpha, where these are the inclination angle of the stirrup. Now if all the things are inclined to same thing, then it will be taken, if all the if in case of bent up bars, or you can say in case of bent up bars, it will be taken as ASB. Okay, these are the formulas, my dear student, in case of bent up bars. So I'll quickly revise the shear concept, my dear students. Here when I talk about shear, I'll write all the things in one topic. So here you can write tau v is equal to Vu upon Bd, that is design shear force by, and you can write here tau v is equal to Vu plus or minus m by d tan beta upon Bd. This is the formula for tau v. And another thing is you can write tau v less than tau c, tau v less than 0.5 tau c, no shear, tau v less than tau c, minimum shear, that is minimum shear reinforcement, that is ASV upon B into SV is equal to 0.4 upon 0.87 Fy. And you can write when tau v is greater than tau c, design shear force tau v minus tau c into BD is equal to design shear force, or you can write design shear force is equal to 0.87 Fy ASV into D upon SV. This is the formula for design shear force. Tau c max depends only on grade of concrete, and it is a check for diagonal compression, whereas tau c depends upon percentage of steel, and it also depends upon grade of concrete. And in case of critical section for simply supported beam, it will be at a distance D, and in case of tension, it will be at the face of the support. So quickly revise this, students. I'll be back in 2 minutes. Okay, I'll be back in 2 minutes. Please revise this. Welcome back, students. We are done with the shear concept as well as the doubly reinforced section. Now we are going to the most important concept, that is the next we are going into the most important concept. What is the most important concept here is the, we can say, T beams. T beams, or you can say L beams. Remember, my dear students, T beams and L beams both are called flange beams. What is T beam and L beam are called as? T beam and L beam are called as flange beams. What is T beam and L beams are called as? T beams and L beams are called as flange beams. T beams and L beams are called as flange beams. Is it clear, my dear students? Is it clear? Talk about the T beam and L beams. First of all, we will talk about the effective width of the flange. So when I talk about the effective width of the flange, in case of T beam, it is given by the formula L0 by 6 plus BW plus 6DF should be less than or equal to C. Should be less than or equal to C. Here what actually L0 is? L0 is the distance between points of zero moments. BW is the width of the web. DF is the depth of the flange. So when I take a T-beam in this case, okay, you can say here the distance between points of zero moments is this can be taken as L0, and this is known as the depth of the flange, and this is known as the breadth of the flange, and this is the breadth of the web. Okay, if you have a steel here, okay, this is known as the effective depth. So when I talk about the effective width of the flange in case of L beam, it will be taken as L0 by 12 plus BW plus 3DF should be less than or equal to C by 2. What is C? Is center to center distance between spans. Okay. So these are all the formulas of effective width of the flange in case of continuous beams. These are the formulas in case of which beam? In case of continuous beam. Similarly, my dear students, when you want to talk about the isolated beam, when you talk about the isolated beam, how do you consider the for T beam, for isolated beam? When I talk about T beam or L beam, if you consider about T beam or if you consider about L beam, the effective width of the flange, the effective width of the flange is taken as L0 by B plus B4 plus BW should be less than or equal to B. That is the actual width of the flange. And here effective width is given by the formula 0.5 L0 upon L0 by B plus B is known as actual width of the flange plus 4 plus BW should be less than or equal to B. Here B is the actual width of the T beam and here B is the actual width of the L beam. So these are the formulas for, these are the two formulas which are important for T beam and L beam. Now my dear students, I will explain you the design of the design of T beams here. So how do you design a T beam? That is important, my dear students. When you talk about the design of a T beam, when you talk about the design of T beam, here remember, my dear students, if suppose XU indicates that XU is less than or equal to DF. What is XU here, my dear students? XU is known as depth of the neutral axis. What is XU known? XU is known as depth of neutral axis. XU is known as depth of the neutral axis. And what is DF? DF is known as depth of the flange. When XU is known as depth of the neutral axis and DF is known as the depth of the flange. DF is known as what? Depth of the flange here, my dear students. So here what I would like to tell you, my dear students, here I would like to tell you one important thing. What is that important thing I would like to tell you here is, so here when you tell XU is less than or equal to DF, what does this mean? Here actually what does this mean is, see here, if this is a T section, my dear students, this indicates that this is DF and your XU is less than DF. So this will be XU somewhere and this is known as DF. So this portion is known as DF. So when XU less than or equal to DF indicates that neutral axis lies in flange. whenever a T-beam, in a T-beam, neutral axis is lying in the flange, then you will design the beam as a rectangular beam. Neutral axis lies in the flange. Lies in the flange. You can clearly write that when neutral axis lies in the flange, what you can tell that is you can design this T-beam as a rectangular beam. You can design this T-beam as a which beam, sir? You can design the T-beam as a rectangular beam. You can design the T-beam as a rectangular beam. Is this clear, my dear students? Is it clear? So what I would like to tell you is when XU is less than or equal to DF, the depth of the neutral, here XU is known as depth of the neutral axis. This indicates that neutral axis lies in the flange, and this T-beam can be defined as a rectangular beam. Okay, thank you. Thank you, Udhanavi. Next one, what I would like to discuss here is the when XU is when 3 by 7 XU is greater than DF. So, sorry. So, here there is another case 2, my dear students. The case 2 here is 3 by 7 XU greater than DF. Here you can say that 3 by 7 XU greater than DF. See here, when I talk of the 3 by 7 XU greater than DF means, suppose here if I have taken this as a T-beam, and if I consider here, first of all, so here somewhere the neutral axis is there, okay? Now see students, whatever I told you here, up to this, see here, this is known up to parabola here, up to here, this is the flange, and here, this is known as 3 by 7 XU, and this is known as 4 by 7 XU, as you know already. Here, this is known as 3 by 7 XU, and this is known as 4 by 7. So, what does 3 by 7 XU greater than DF? First of all, for this condition, when XU is greater than DF, when depth of the neutral axis is greater than DF, it indicates that neutral axis lies in flange. This indicates what, my dear students? This indicates that neutral axis lies in flange. This is the first and the foremost thing which I would like to tell you. This indicates that neutral axis lies where? Neutral axis lies in flange. The next thing, what does 3 by 7 XU indicates? DF means the stress here is uniform. So you can take the stress here is how much? 0.44 FCK. So how do you calculate compression force here is? So if I idealize this student, this can be divided in this way. This part is flange and this entire part is web. So here, if I take here to here, the distance is breadth of the flange and this distance is breadth of the web. So when I talk about the compression force due to flange, so due to flange it can be taken as 0.45 FCK because the stress here is 0.45 FCK into area, that is breadth of the flange minus breadth of the web into DF. DF means this is the DF is nothing but depth of the flange. So in this case, this is the stress and this is the area. So 0.45 FCK BF minus B. This is the compression force due to what? This is the compression force due to flange. Plus, what I would like to add here is, here we have a compression force. Here we have, this is the compression force due to the rectangular section, that you can directly take it as 0.36 FCK BW into XU. BW into XU is what? BW into XU is nothing but the width of the, because it is a rectangular beam. So I have taken BW is the width of the web. Am I clear? Now see students, for the same question, if you want to talk about the moment, you can write here 0.45 FCK into breadth of the flange minus breadth of the web into DF plus 0.36 FCK into BW into XU. Okay, here we have taken to take the moment. So this can be taken as D minus DF by 2. And here it will be taken as, here what is the rectangular portion? It is D minus 0.42 XU. So this is how you calculate the moment. This is how you calculate the moment in case of a T-beam. This is how you calculate the moment. Suppose, my dear students, in the case 3, is what I would like to tell you in case 3 here is when 3/7 XU is less than DF. This is a very important thing, my dear student. First of all, try to understand this case. When XU is greater than DF, this indicates that neutral axis lies in flange. This everyone can understand. When XU is greater than DX, neutral axis lies in web. Neutral axis lies in web. This will be understand. But what does this 3/7 XU greater than DF? This is important, my dear student. Here, what I would like to tell you here is, if we consider a T-beam here, what I would like to tell you, here if we consider 3/7 XU, what is 3/7 XU means? Here. So here what he is telling is 3/7 XU is less than DF. So this diagram we have to, so here what is 3/7 XU? So here we can say here like this. So this is 3/7 XU. So here the stress is not uniform. The stress is going to vary into the entire depth. Here you can understand that stress is not uniform. The stress is not uniform. That is the important thing. So you cannot take depth of the flange here. Are you getting me? So there was a concept from IS 456 code. The concept, there is a concept from where? There is a concept from IS 456 code. What does this code, IS 456 code is saying is, this IS 456 code says that wherever you find DF, replace DF with YF. Replace DF with what? YF. So what is YF? YF is equal to, this was taken from the code, 0.15 XU plus 0.65 DF. So this is the formula which you have to use when XU is greater than DF and 3/7 XU is less than DF. So whatever the formulas you have adopted earlier, replace DF with YF there, this problem can be solved. Is it clear for everyone, my dear students? So this is how we describe the formulas related to what? About the T-beam or the flange beams. So I hope you are clear with the T-beam and L-beam. So the next important topic I would like to talk here is the torsion. Now, my dear students, I will be more concentrating on the formulas itself. Torsion is based on skew bending theory. See, we have grid beams or canopy beams. Suppose, see students, in these cases, whenever you find a grid beams of this kind or in case of canopy beams, okay, you will find the things of torsion. So what actually, whenever a torsion is going to happen, here there comes a concept of VE. What is VE means? Here VE we will talk about the equivalent shear. Here we talk about the equivalent shear. So here what I would like to tell you here is, when you talk about the equivalent shear, we talk that VU is equal to, the equivalent shear is equal to VU plus 1.6 into TU by B. So whenever there is a torsion, there will be an additional shear stress, that is 1.6 into TU by B. Is it clear, my dear students? So the torsion for the equivalent shear is given by the formula VE is equal to VU plus 1.6 into TU by B. Similarly, my dear students, when I talk about the moment due to torsion, moment due to torsion is given by the formula TU into 1 plus D upon B upon 1.7. So this is the formula for moment due to torsion when there is a moment due to. So here also equivalent moment is given as ultimate moment plus moment due to torsion. So this is also another important formula. Equivalent moment is given by mu greater than mt. Sorry, mu plus mt. So you have to remember the torsional moment. This is the torsion. See, T is known as torsional moment or moment due to torsion is given by the formula Tu into 1 plus. So whenever there is one more question, my dear students, when moment due to torsion is greater than mu, in this case you will design for moment due to torsion minus ultimate moment. Actually, you will usually, when there is a torsion, you will design for equivalent moment, but whenever the moment due to torsion is greater than the ultimate moment, then in that case you will design for moment due to torsion minus mu. So what actually is torsion? When you are pedaling, when you are cycling the things in a radial motion, or in a case of polar coordinates, that is in a plane, you can say it is a bending. When you talk about in a cycling or in a rotatory motion, then you can call it as a torsion. So here what I would like to tell you, the most important 2 points is moment due to torsion is given by the formula Tu into 1 plus d by b upon 1.7. This is the moment due to torsion formula. This is the formula due to moment due to torsion. And another important formula I would like to tell you is equivalent moment is equal to mu plus mt, which I have told you already. And similarly, equivalent shear is equal to Vu plus 1.6 into Tu by B. Now, when I talk about the torsion, see my dear students, I told you clearly, side face reinforcement is provided. I told you clearly, side face reinforcement is provided. Side face reinforcement is provided when depth of the beam exceeds 750 mm, right? But in case of torsion, when depth of the beam exceeds 450 mm itself, you have to provide the side face reinforcement. This is another important. When do you provide side face reinforcement is when the depth of the beam, when you say the depth of the beam is exceeding 450 mm itself, then only the side face reinforcement will be provided. Is this clear for everyone? Is it clear for everyone? Okay. Next, we have bond. Actually, bond is a kind of shear, sir. It is nothing but shear. Here in the bond, we have an important formula, that is development length, and development length is given by the formula phi into sigma s upon 4 into tau bd, or some people will write the stress in steel can be taken as 0.87 Fy, where phi is the dia of the bar and tau bd is the bond stress. Tau bd is the bond stress. So this is the nothing but the development length. What is development length is the embedded length in the contour of the concrete to hold the concrete and steel together. So that extra length which is embedded in the concrete is known as the development length, and the development length should be less than or equal to m by v, the moment plus v plus L naught, or in case of compression, the development length should be less than or equal to 1 by 3 m by v plus L naught in case of what, sir? In case of compression. And usually in case of tor bar, when tau by d will be increased by 60%, and in case of compression, it will be further increased by, means here it will be taken as 1.6 tau by d in case of tor bar. If you consider in case of compression, it will be taken as 2 tau bd, or some people will tell you it is increased this value by 25%, and that will be also equal to, so 60% 1.6 tau b, and this is 2 tau bd. Okay, this is the one I would like to tell you. So what is development length? Thank you, Irfan, thank you. Okay, here what is development length is, development length is taken as phi, means here dia of the bar, sigma s is the stress in steel, and tau bd is the bound stress. So my dear students, as I told you, foundation, see, foundation is another important concept. Before moving to the columns, I would like to discuss about the foundation. So what is a structure actually? What is a structure, my dear students? A group of structural elements connected together is known as foundation. As I told you, for every structural element, there will be a design criteria. If you are designing a beam, so for designing a beam, what you can tell you here is, the bending is the design criteria. When you are talking about a column, you can say buckling is the major criteria. When you talk about short column, crushing. In case of slabs, it is deflection. Similarly, in case of foundation, we talk about a shear. Why do you want to talk about shear here is, remember my dear students, we are talking the shear because the depth of the foundation depends upon shear. This is a very important competitive question. Remember always, why do you want to consider shear in foundation is, the depth of the foundation usually depends upon the shear. That is the reason. Now, another important thing I would like to tell you here is, when I talk about the foundation, what is the minimum depth of the foundation? Sir, the minimum depth of the foundation, when I talk about the minimum depth of foundation, the minimum depth of the foundation is equal to 500 mm. What, sir? Minimum depth of the foundation is equal to 500 mm, or minimum depth of the foundation is given by the formula Q by gamma into 1 minus, this was given by Rankine's formula, Q by gamma into 1 minus sin phi by 1 plus sin phi whole square. So here this formula is given from the code, this is minimum depth, and this formula is given from the soil point of view, where Q is the intensity of pressure, gamma is the unit weight of soil. Good evening Irfan. Sin phi is the angle of repose. So here the minimum depth of the foundation is Q by gamma into 1 minus sin phi upon 1 plus sin phi whole square. Is this clear, my dear students? So when I talk about the minimum depth, so here also you can ask you, what is the minimum clear cover? What is the minimum clear cover for foundation is 50 mm. This is also another important thing you should remember. So here I would like to tell you one more thing, my dear students. The critical section, suppose if I have taken a column, suppose this is the footing, and where will be the critical section for bending, sorry, for movement? Where will be the critical section for movement? The critical section for movement in foundation will be at the face of the column. This is very, very important. It will be at where? The critical section for movement calculation will be at face of column. Similarly, my dear students, similarly when I talk about a foundation, and if you have a column here, so if you consider here, so this is the critical section will be at a distance d. So here what I would like to tell you here is, for in case of one-way shear, the critical section will be at a distance d. So in case of one-way shear, this can be asked, my dear students, in the problem. In case of one-way shear, the critical section will be at a distance d. Now, my dear students, when I talk about at a distance d, when I talk about the design shear force, if I consider this as the length of the footing and this is the width of the footing, or Q is the, so here what I can write is design shear force is equal to Q naught, that is intensity of pressure, the entire area. So you have to take this area only. What is this area? The center area will be L by 2, and if take the size of the column as A and B, rectangular column A and B, so this can be taken as what, my dear students? L by 2 minus A by 2 minus D into, sir, it is acting along one side, this face is B. So this is the design shear force. This is the design shear force in case of one-way shear. Similarly, my dear students, when I talk about the two-way shear, one more thing, my dear students, whenever you are calculating the normal stress in case of one-way shear, you will take VU by BD, right? This B will be replaced by capital B. Why it is replaced by capital B is, it is acting along the width. So here it will be taken as B. Is it clear, my dear students? Is this clear? So similarly, when I talk about the two-way shear, how, see, my dear students, how do we consider this? So the two-way shear is going to act at a distance d by 2. This is going to act at a distance d by 2. So what is a two-way shear? In case of two-way shear, what is the design shear force? The two-way shear, the design shear force is given by the formula intensity of pressure. Now, my dear student, this is the length of the footing and this is the width of the footing. Are you clear? And if I consider this as the size of the column, you can write L into B. This is the total area of the footing minus this shaded area. How do you get that shaded area? So you can write here A plus D into B plus D. So this will give you the design shear force in case of two-way shear. But remember, my dear students, here one logic is there. When you talk about the nominal shear stress in case of two-way shear, so you know already how do you calculate the nominal shear stress? How do you calculate the nominal shear stress is you will calculate the value by VU into BD. Now, what is this B will be taken as? This B will be taken as this circumference. So, here this circumference will be taken as perimeter, that is 2 into A plus D plus B plus D. These things are very, very important, my dear students. Similarly, my dear students, when you talk about the reinforcement in a wall, when you talk about the reinforcement, we divide the footing. See, footing can be also designed as an inverted slab. We consider this as a central band. So, what will be the area of steel provided in the central band? Or you can write area of steel in the central band will be taken as 2 into beta plus 1 into AST. Okay. So, here beta will be always greater than 1. Beta will be taken as longer side of the footing upon shorter side of the footing, because whatever the area of steel provided in central band will be definitely less than the total area of steel. So, beta will be greater than this. That's what I want to tell you. Or AST central band will be always less than AST. That is how you can also remember. So, next one I would like to talk here is the column, my dear student. Next one I would like to talk here is the column. When I talk about the column, my dear students, you have two things. One is a short column and other one is a short column we have. When you talk about a column, you have two things. One is short column and other one is long column. So here what I would like to tell you, when I talk about short column or long column, short column will fail by crushing. Short column will fail by what, my dear students? Short column will fail by crushing and long column will fail by buckling. Okay, see, actually any column, if you consider any column, actually even though, see, my dear students, every column, if this is an axis, if you apply load at this point, you will assume this as axially loaded column. So if you consider a column here, or okay, now if it is applied at the center of the neutral axis, you say that it is an axially loaded column. But what I would like to tell you is, every column, due to like skill, means if there is any skill error or due to misplacement of the load or anything, every column will be designed for minimum eccentricity. In a column, every column will be taken as what, sir? Every column will be designed for minimum eccentricity. So what is the minimum eccentricity is? Minimum eccentricity will be taken as 20 mm, or it can be taken as unsupported length by 30, sorry, unsupported length upon 500 plus least lateral dimension plus 30 plus least lateral dimension by. So what is the minimum eccentricity formula is unsupported length by 500 plus least lateral dimension by 30. Here unsupported length usually will be taken in meters, but you will have to convert meters into the mm. So what is the minimum eccentricity formula? It can be 20 mm or unsupported length by 500 plus least lateral dimension by 30. Now my dear students, why I will tell you. Now there is an important formula for a column. When you talk about the ultimate load of a column, you will design the ultimate load of a column is equal to 0.4 FCK, 0.4 FCK AC plus 0.67 FY ASC. So here, my dear students, this is the due to column, this is due to concrete, okay, and this is due to steel. I'll tell you what is ASC. AC is the area of concrete. You can say AC is the area of concrete. And what is ASC? ASC is known as the area of steel in compression. What is AST? AST is known as the area of steel in area of steel in compression. Am I clear, my dear students? So when I talk here, this is one of the important things. See, actually the stress should be 0.45, right, my dear students? And this should be also 0.87. But why these are not taken into account is, as I told you, every column is designed for minimum eccentricity, and we are, even though it can carry more load, you will tell that it carries lesser load. So that is the intention here. And another thing, if they can ask you, if a column is designed for in the one of the previous gate question they have given this in 2018, or I am not sure about the date, but in 18 or 17 they have given with a column with eccentricity 0, then what will be the ultimate load? In this case, the ultimate load is given by the formula 0.45 FCK 0.45 FCK into ASC plus 0.75 F5 ASC. So what is ASC? Area of steel in compression. Or you can write ASC AG minus gross area minus, or you can write in the other way also, okay? Anything is fine. So this is the formula in case of what? In case of zero eccentricity. This is very, very important, my dear students. This is very, very important. What I would like to tell you here is, when you talk about the ultimate load, when you talk about the ultimate load, here you should talk about that 0.45 FCKAC. This is due to concrete and this is due to steel. So the ultimate load carrying capacity will definitely increase when there is a zero eccentricity. Okay. So these are the another important formulas which I would like to tell you. Now my dear students, so here what I would like to tell you here is the next important thing. So what is the minimum number of bars for a rectangular column, or see for a rectangle or for a square according to IS 456? For a rectangular column it is 4 number. For a square column, it is also 4. For a hexagon, if you see, for a hexagon or for a circle, it is equal to 6. The minimum number of bars, okay? And the minimum dia of bar for a column. What is the minimum dia of bar for a column is, the minimum dia of bar for column is 12 mm. You can ask me why it is 12 mm, sir? Because the reason here is to avoid buckling. To avoid buckling, they are providing 12 mm bar. They are to avoid the buckling, they are providing the 12 mm bar. So here what is the minimum number of bars is rectangle, square, circle. So these are the values. So these are the values which are required for the minimum number of bars. So here why do you provide 12 mm bar is to avoid, the necessity is to avoid the buckling. So there can be conditions also, my dear students. According to the code, actually you might have studied in a strength of materials, when both ends are fixed, you might have studied it as 0.5 L. Here it will be equal to how much, my dear students? Here anyone, can you explain me? Here according to the IS 456, it will be equal to 0.65 L. So these values also you have to remember. So these values also you have to remember, my dear students. So we have different values also. Okay, when both ends are hinged also, when both ends are hinged, then it is equal to L. Okay, so these effective lengths are also you have to remember. So this is what we are discussing about the column. So before moving to pre-stressed concrete, I'll give you a 5-minute break, students. Please be tuned. I'll be back in 5 minutes. Okay. Or if you want to see any image. Okay. If you want to see any class, 1 second, because if we have done the summarizing part also, you can see. So this is the summarizing part which you can see. Okay, welcome back, students. The next topic, which is very important topic, that is nothing but the pre-stressed concrete. The next topic which I am going to discuss is the pre-stressed concrete. Okay. So what exactly is pre-stressed concrete here? Here, what exactly is pre-stressed concrete is important, my dear student. We have to talk about the pre-stressed concrete. Here, what exactly do you mean by the pre-stressed concrete? So what do you mean by pre-stressed concrete here is, here whenever, see my dear students, when I talk about the pre-stressed concrete, the internal stresses are deliberately introduced. There are some stresses. So the stresses will be deliberately, or you can say intentionally. You are introducing the stresses intentionally, or you can say deliberately, to counter the stresses to a desired extent by the applied loads. So what do you mean by pre-stressed concrete? Whatever the stresses which are intentional, the stresses will be intentionally introduced, and those stresses will be counterattacked by the stresses which are induced due to the dead loads. Now, when do you go with here, what I would like to tell you here, 1 second, students. See here, what I would like to tell you here is, when do you go with a pre-stressed concrete? When do you go with a pre-stressed concrete? So see, students, or you can say, what are the advantages of pre-stressed concrete? The advantages of pre-stressed concrete is simple. It offers more resistance. Pre-stressed concrete offers more resistance to impact loading. What is an impact load? Means a load falling from a height. It offers more resistance to impact loading, or you can say it offers more resistance to vibration loading, or it offers more resistance to fatigue loading. What do you mean by fatigue loading? You can say it is a repeated load. So whenever you say what are the advantages of pre-stressed concrete is, it offers more resistance to impact loading, vibrational loading, and fatigue loading. What is a fatigue loading? You can say it is a cyclic loading. Next, these are best fit for water retaining structures. If you see in the water retaining structures, pre-stressed concrete or suppose if you see all the Indian metro railway stations, almost all the things are pre-stressed concrete only. And in pre-stressed concrete, deflections will be less. And you can also remember that in pre-stressed concrete, deflections will be less. And one more major advantage of pre-stressed concrete is the cross section is efficiently used. In pre-stressed concrete, whatever the cross section is there, my dear students, that cross section is efficiently utilized. You can say in pre-stressed concrete, the cross section is efficiently utilized. So what are the advantages of pre-stressed concrete is, the advantage it offers more resistance to impact loading, vibration loading, and fatigue loading. It is the best in case of water retaining structures, and deflections are less, and the cross section is efficiently utilized in pre-stressed concrete. The next important thing I would like to tell you here is, when you talk about the pre-stressed concretes, so why do you go with high strength concrete, or why do you go with high strength steel in pre-stressed concrete? This is one of the most important interview questions. After getting a better grade score, if you have been into any of the IITs, they can ask you what is the necessity of providing high strength concrete and high strength steel. Suppose, my dear students, I will give you a best example. If you are using Fe250, which you usually don't use, if you are using Fe250, the workable stress will be 140 Newton per mm square, because almost 50%, 110 Newton per mm square is lost due to the losses of pre-stressed concrete, which is a separate chapter. So the losses here can be due to the elastic deformation of concrete, or shrinkage of concrete, or creep of concrete. And these can be the reasons why, as the losses are more, we are going to use high strength concrete and high strength steel. So this is the one of the thing I would like to add. Now when I talk about the methods, or you can say when I talk about the methods of pre-stressing, what are the different methods of pre-stressing? When I talk about what are the different methods of pre-stressing, is the different methods of pre-stressing is, one is we have is the pre-tensioning, So when I talk about the pre-tensioning, what is the minimum grade of concrete is M40. The minimum grade of concrete is M40 for pre-tensioning concrete. So when I talk about pre-tensioning, the wires are tensioned before casting of concrete. So how these wires are tensioned? These wires are, you can say, tendon. A group of wires tied together is known as a tendon. So when I talk about pre-tensioning means the wires are tensioned with the help of hydraulic jogs. So here that's what I would like to tell you. Now after tensioning, then you will do the casting. So here what do you mean by pre-tensioning means? The tendons are tensioned with the help of hydraulic jacks, and after that casting of concrete will takes place. And these how how they are tensioned by hydraulic jacks. And remember, bond is the main factor for transfer of stresses. So which is the main factor for transfer of stresses in pre-tension is bond. And remember, we have different methods like you can say long line process. You can have a process called long line process or Hoyer's method. These are the two methods which are applicable in pre-tensioning. So remember, these are useful if you consider the application of pre-tensioning. Railway sleepers. See, the railway sleepers application, the pre-tensioning concrete, pre-tensioning thing is used. So when I talk about the pre-tensioning, here the tensioning is applied by the hydraulic jogs, and after applying the tensioning, you will be doing the casting. And bond is the main factor for transfer of stresses. If you want to produce long bulk production of railway sleepers and all, long line process or Hoyer's method is useful for mass production of the sleepers. The next one we have is the post tensioning operation. Next one we have is what, my dear student? Next one we have is the post tensioning operation. Here what do you mean by post tensioning operation is, here there will be a gutter. In this gutter you will have the holes, you can say ducts. In these ducts, these tendons are introduced and then they are tensioned. Okay, the space between the tendon and duct is filled with, or it is grouted. So here whatever the grouting is done, the grouting should have a minimum pressure of 0.7 MPa, and the fine sand should be less. The sand should passing through 150 micron, whichever is used in the grout. So post tension, which is the main factor for transfer of stresses for post tension, is, you can say, end bearing. End bearing is the main factor. You can say end bearing is the main factor for transfer of, end bearing is the main factor for transfer of stresses in case of post tensioning. And one more thing I would like to tell you, my dear students, when I talk about the post tensioning operation here, I would like to tell you one important thing. So which method is used for post tensioning is Magnal system, and this post tensioning is helpful for long spans. In case of bridges and all, this post tensioning technique is used. I hope you are clear with the pre-tensioning and post-tensioning. End bearing is the main factor for transfer of stresses in post-tension, and bond is the main factor of transfer of stresses in steel and concrete. Now, my dear students, here I would like to tell you the analysis of pre-stressed concrete. When I talk about the analysis of pre-stressed concrete also, here see, concrete is assumed as a homogeneous elastic material, or within the range of working stress and steel behaves elastically. Steel and concrete behave elastically. That means the stress strain behavior and the will be linear. So what are the analysis of, suppose if I have taken a rectangular section, my dear students, if I have taken a, one second. Suppose if I have taken a rectangular section, okay, if we consider this. Now see students, due to the, see, when I consider a section as beam, okay, which is tensioned with an eccentricity P, with a pre-stressing force P, which is located at an eccentricity E. Okay. In this case, I'll show the analysis diagram. So, see students, the first thing is due to direct stress. Due to direct stress, the stress will be P by A. And if we consider due to the pre-stressing force, this will be equal to PE by ZT, that is section modulus at top, and this is the PE by ZB due to section modulus at bottom. How this formula came, you know, M by A is equal to F by Y, and you know bending stress is equal to what? M into Y upon I, and you know Y by I, this can be written as M upon I by Y, where I by Y can be written as section modulus, and what is M? Moment is taken as load into eccentricity. So here bending stress can be taken as PE upon Z. So the bending stress can be taken as PE. From there the formula has been kept. And if you take the moment due to dead load, this will be equal to, one second students. So it will be equal to moment, this will be equal to moment upon ZT, dead load, and this is due to moment dead load upon ZB. And similarly, if we take here, this will be equal to moment upon live load into ZT, and this will be equal to moment upon live load upon Z bottom. So here, when we consider the analysis here, so if we consider here, my dear students, I would like to tell you one important thing. So here, the stress at top is given by the formula P by A minus PE by ZT plus MD plus ML, moment due to dead load, plus moment due to live load upon ZT. And if I take the stress at bottom, it will be equal to P by A plus PE by ZB minus of MD plus ML upon ZB. So here what I would like to tell you, my dear students, the stress at top is P by A plus PE by ZT plus, or you can say, sorry, here it is, minus plus MD plus ML upon ZD. Similarly, the stress at bottom will be taken as P by A plus ZB minus MD plus ML upon ZB. So this is the stress at top and this is the stress at bottom. So here what I would like to tell you, my dear students, so when I take with, they will tell you concentric tendon. When they take concentric tendon, what you can write here is eccentricity will be 0. This entire part will be taken as 0. Okay, if you want to take, there is no dead load is 0, then take only these two parts. So if you know the stress formulas of this, if there is no eccentricity, substitute eccentricity as 0. If there is moment due to dead load or live load is 0, you can. If you know these two formulas, any problem can be done in analysis. And one more thing, my dear students, if they tell you no tension in the problem, usually in gate questions you will see this problem. They will tell you there is no tension at bottom. So when they tell you, usually when they tell you no tension, you have to assume that stress at bottom will be equal to 0. Or if they tell you SOFIT means at the bottom. So when they tell you to avoid no tension, what is the condition is the stress at the bottom is 0. So this is the basic formulas. If you can remember these two formulas, any problem can be solved in pre-stressed concrete. Now, there is a concept called P line. What exactly P line means? Actually, when you take a beam, okay, there will be neutral axis here. See, this is the eccentrical loading and you have the pre-stressing force here, and here you also have the pre-stressing force, and here you will have the dead load or live load. So what happens is the pre-stressing force and the dead load, they combine into a single force, and the resultant of those stresses, if you draw a graph, that will be somewhere like this. The locus of those points, the stresses at individual locations, the locus of those points is nothing but P line. What is a P line or a thrust line? They can also ask you. what is a P line, or they can ask you what is a thrust line. A P line or a thrust line is nothing but the pre-stressing force, the combined effect of the pre-stressing force and the applied load will resolve into a single force, and the distribution of these the distribution of stresses due to these forces will be drawn, and this is known as a P line or thrust line. This is known as what, sir? This is known as P line or thrust line. Am I clear, my dear students? Next, see here, there is a concept called also load balancing concept. What is the load balancing concept here is, simply I will tell you, my dear student. They will give you usually parabolic profile. I will tell you the basic concept. What is a parabolic profile? When do you see that, or parabolic profile tendon, they will tell you. When do you see that in bending moment parabolic thing? In case of UDL, suppose if they have given you example, I am giving with an example. If they give you an UDL load, in this case it will be parabola. And what is the maximum stress here? The maximum stress here, it will be equal to how much, sir? It will be somewhere W square into E. Now see students, if I have taken a pre-stressed concrete beam, and if I consider this as a neutral axis, and if you have a tendon here, and you are applying a pre-stressing force here, and if you are applying a pre-stressing, and you are having an eccentricity E, and this is load. So what will be the moment? Moment will be equal to P into E. This is the moment due to what? Pre-stressing force. And moment due to dead load, if you consider as a parabolic tendon, it will be equal to WL square by 8. If you equate these two, eccentricity will be equal to WL square by 8P. Or if it is a triangular tendon, it will be equal to WL by 4. So based on the loading conditions, it will be a triangular tendon or parabolic. See, actually they will give you the profile of the tendon. Based on that, you have to assume what is the maximum bending moments. So the load or the moment which is obtained due to the pre-stressing force is balanced by the moment due to the applied loads or dead loads. That is nothing but load balancing concept. And one more thing, in pre-stressed concrete, we have design in pre-stressed concrete. In design, we have type 1. Type 1 is something like no tensile stresses. If you take type 1 design is, you will not allow tensile stresses. Okay, no tensile stresses, then you will tell that it is a type 1 pre-stressed concrete. In type 2, tensile stresses are allowed, but no cracking. Here you can say no cracking, but tensile stresses you can say no cracking, or you can say tensile stresses are allowed. When no cracking or tensile stresses are allowed, then it is known as what, my dear students? Then it is known as type 2. And similarly, if I consider type 3, okay, what do you mean by type 3 here is, this is one of the important things. So when I talk about the type 3, cracking is allowed, but it should not exceed the maximum values. So these things also will help you to understand the different types of design. So here in pre-stressed concrete, we have type 1 is no tensile stresses, and in type 2 no cracking, tensile stresses are allowed. In type 3 cracking is allowed. So the next important part, the very next important part we have is losses of pre-stressed concrete. Very, very important. This year, my dear students, what are the expected questions is either from beams, LSM method, loss of pre-stressed, or you can say LSM method analysis. This is my guess. It is not sure. And here you can expect a question from shear or the fundamental concept. This year, the 4 marks one can be expected from these 4 topics, I am thinking. So whenever you are concentrating on RCC, apart from the other topics, please give this highest priority. Okay. Now see, students, when I talk about loss of pre-stressed concrete, when I talk about the loss of pre-stressed concrete, we have different types of losses. One is elastic shortening of concrete. The first one we have is the elastic shortening of concrete. The first one we have is the elastic shortening of concrete. Next one is shrinkage of concrete. Next one we have is creep of concrete. And next one we have is the relaxation of stress in steel. Next one we have is the relaxation of stress in steel. Relaxation of stress in steel. So here what I would like to tell you here is, what are the different losses of pre-stressed concrete? The different losses of pre-stressed concrete is, one is the elastic shortening, shrinkage of concrete, creep of concrete and relaxation. Now my dear students, all these losses are observed both in pre-tension as well as post-tension. The losses which are observed in both pre-tension and post-tension are elastic shortening, shrinkage of concrete, creep of concrete and relaxation of stress in steel. But my dear students, when I talk about two losses, we have two losses. What are the two losses is, the first, these like frictional loss. Okay, frictional loss or loss due to anchorage slip or loss due to anchorage slip. Frictional loss or loss due to anchorage slip. Frictional loss or loss due to anchorage slip. These two losses are specific to post tension. These two losses are specific to what, sir? These two losses are specific to post tension. So whenever there are losses like frictional loss or anchorage slip, these two losses are observed in post tension. Next, we'll discuss individually loss. Now, my dear students, when I talk about the loss due to elastic shortening. So, see, this is very important, my dear students. The loss due to elastic shortening is, see here, the loss due to elastic shortening of concrete is given by the formula. The loss due to elastic shortening is given by the formula M into Fc. The loss due to elastic shortening is given by the formula M into Fc, where M is the modular ratio, Fc is the, this is very important, my dear students, stress at the level of steel. Most of the people will do wrong here, my dear students. What is stress at the level of steel? This, please underline this and important. So here you know how do you calculate modular ratio, Young's modulus of steel upon Young's modulus of concrete. If they have not given Young's modulus of concrete, you can calculate 5000 root FCK. Or Fc is taken as stress at the level of steel, that is load by area plus PE square upon I, because here when I talk about the section modulus, here it will be taken as I by E. Usually it will be taken as I by D by 2. Why? Why we are taking E means because that is at the level of steel. This is important. What do you mean by elastic shortening here is, when the pre-stressing force is applied, a shortening of concrete takes place. Due to that shortening, the elastic shortening of concrete is given by the formula M into Fc, where M is the modular ratio, Fc is the stress at the level of the steel. The stress at the level of the steel is given by the formula P by A plus PE square by I. Please underline the word level of steel. And modular ratio is given by Young's modulus of steel upon Young's modulus of concrete. I hope you are clear. But here there is one more thing. If you consider a post-tensioning operation, if all the tendons are tensioned simultaneously, then there will be no loss due to elastic shortening. In post-tensioning, if all the wires are tensioned at a time, there will be no loss due to That's what I would like to tell you. So here, my dear students, when I talk about the loss due to elastic shortening means when all the wires are tensioned at a time in a post-tensioning operation, there will be no loss due to post-tensioning. No loss due to elastic shortening in post-tension. Next one we have is the shrinkage of concrete. Sir, what do you mean by shrinkage? Shrinkage is nothing but volume. Shrinkage is nothing but loss due to shrinkage of concrete. So when I talk about the loss due to shrinkage is nothing but volume reduction. Now what are the factors which can affect shrinkage is the type of the aggregate which you are using, and what is the curing. If you increase the strength of the concrete, definitely strength will increase, but at the same time shrinkage will also increase. So here it is given, loss due to shrinkage of concrete is given by the formula ES into Young's modulus. So here what is ES means? Here ES is known as shrinkage strain. Here ES is known as shrinkage strain, and shrinkage strain is equal to 3 into 10 power minus 4. Shrinkage strain is given as 3 into 10 power minus 4 for shrinkage strain in case of, this is the value in case of, pre-tensioning operation. This is the value in case of pre-tensioning operation. And when I talk about the shrinkage strain in case of post-tensioning operation, this will be equal to 2 into 10 power minus 4 upon log 10 into T plus 2, where T is the age of concrete in days. So what I would like to tell you here is, when I talk about the loss due to shrinkage of concrete, it is given by the formula shrinkage strain into Young's modulus. Shrinkage strain is 3 into 10 power minus 4 for pre-tensioning, and 2 into 10 power minus 4 upon log 10 into T plus 2. This is the formula. And shrinkage is due to what, sir? Here there are two different formulas for shrinkage strain. What is ES is the Young's modulus of steel. Next we have is the creep of concrete. What do you mean loss due to creep of concrete? When I talk about loss due to creep of concrete, so pre-stressing loss due to creep of concrete. When I talk about what is creep, a creep is nothing but a long-term deflection under constant loads. When I talk about creep, it is a long-term deflection under constant loads is nothing but a creep. So when I talk about the creep, the loss due to creep of concrete is given by the formula phi into M into Fc. Or you can also write that phi into loss due to elastic shortening. So you can write here phi into loss due to elastic shortening. So here what is phi? If your loss due to elastic shortening is nothing but M into Fc, you can write here this one also. So what is phi here? Phi is nothing but creep coefficient. Loss due to creep of concrete, phi is known as creep coefficient, where creep coefficient is defined as ultimate creep upon elastic creep. Creep coefficient is defined as, the ultimate creep upon, elastic creep. That's what I would like to tell you in case of creep coefficient. Is this clear? What is phi, my dear students? Phi is known as the creep coefficient, which I would like to tell you. Next, when I talk about the loss due to relaxation of stress in steel. Sir, see, my dear students, when I talk about relaxation of stress in steel, what do you mean by relaxation of stress? It is similar to creep of concrete. When I talk about relaxation of stress in steel, it is similar to creep of concrete, or it is the loss in stress in steel under constant temperature at constant, you can say at constant temperature and constant humidity. So here what is the relaxation means? Actually whatever the loss observed in steel due to constant temperature under constant strain, this is called relaxation. Actually the relaxation of stress varies from manufacturers. Suppose if there is a manufacturing from Tata unit, you will see the stress, the loss will be different. If it is from Jindal, it will be different. So that's how the losses will be different in different manufacturers. So in this case, they have given a table for a loss of 0, for the yield strength of 0.5, the loss is 0. And for 0.67 yield stress, it is 35. And for 0.7 Fy, it is 70. And for 0.85 Fy, it is 90. Because usually at 50% it is loss is 0. So we need not to go beyond, lesser than that. Why we are not going beyond 0.8 is the maximum yielding stress is 0.87 Fy. So you cannot go beyond 0.8. That is the reason we have not mentioned 0.4 Fy or 0.9 Fy. Is it clear, my dear students? Next one we have is the loss due to friction. Okay, loss due to friction. Now the loss of pre-stress, or you can like loss of pre-stress due to friction. This is very important. Loss due to friction is given by the formula P naught into mu alpha plus K into X bar. This is the formula for loss of pre-stress due to friction. What is P naught here? P naught is nothing but the initial stress. What is P naught here? P naught is taken as initial stress. And what is mu? Mu is known as coefficient of friction. What is mu, sir? Mu is known as coefficient of friction. Mu is known as coefficient of friction. Alpha is known as cumulative angle in radians. What is alpha? Alpha is known as cumulative angle in radians. Alpha is known as cumulative angle in radians. K is known as Wobbling constant. K is known as wobbling constant. What is wobbling constant means? Actually, if you see a wire, it will be actually straight, but if you see, it will be somewhere like this. So that is called wobble effect. And what is X bar is? It is nothing but the length of the span. Now, my dear students, they can ask you, if the cable is tensioned from both ends, if you see, if it is cable is tensioned from both the ends, okay, so in this case, P naught will be taken as P naught by 2. If it is tensioned from one end, then it will be taken as P naught only. So this is also, so here the loss of pre-stress due to friction is given by delta P is equal to P naught into mu alpha plus K into X bar. P naught is the initial stress, mu is the coefficient of friction, alpha is the cumulative angle in radians, and K is the wobbling constant, X bar is the length of the span. Now, my dear students, if I consider this as a beam, see here, if this is the neutral axis, and if I consider this as theta, and this one as theta 1, theta 2. For example, if they ask you what is cumulative angle is, alpha will be taken as theta 1 plus theta 2. As it is a parabolic tendon, how do you calculate this is y is equal to 4h by L square into x into L minus x. If you calculate the differentiation dy by dx, then for small values of theta, tan theta will be equal to theta. That will be equal to 4h by L. 4h by L. If you want to know alpha here, you can say h is nothing but the eccentricity here. So you can write a 4h by L plus 4h by L. I am giving an example how you can solve. It will be taken as 8h by L, or you can write 8e by L. How to calculate the cumulative angle in radians. This is what. And the last one we are going to discuss here is the loss of pre-stress. Loss of pre-stress due to slip. See, my dear students, when I talk about the pre-stressed concrete, in case of post-tension, you will have ducts. So when you do the tensioning operation of the tendon, whatever the tendon you are having, when you do the tensioning operation, when you release it, there will be a slip. So the loss due to anchorage slip, you know what is Young's modulus? Young's modulus is taken as stress upon strain. Or you can say stress upon strain is nothing but Young's modulus. Or if you see here, loss of stress can be taken as Young's modulus into strain. Strain can be taken as delta L by L, where delta L is the slip and L is the length of the tendon. You can say loss of pre-stress due to anchorage slip is ES into delta L by L. And remember, even though there are two additional losses in post-tension, always the losses will be more in pre-tension when compared to the post-tensioning. So here I will try to write all the losses formulas. First, loss due to elastic shortening. I will write in shortcut some. Loss due to elastic shortening is given by the formula. Elastic shortening is given by the formula M into FC, where M is the modular ratio. That is Young's modulus of steel upon Young's modulus of concrete. Young's modulus of, and FC is equal to load by area plus PE square upon I. This is the formula for, okay. Now similarly, when I talk about the loss due to creep of concrete, it is given as phi into M into FC, where phi is the creep coefficient. Are you getting, my dear students? When I talk about the shrinkage of concrete, it is given as, you can say, shrinkage strain into Young's modulus of steel. Shrinkage strain is 3 into 10 power minus 4 for pre, and this will be equal to 2 into 10 power minus 4 upon log 10 into 10 plus t plus 2, where t is the age of concrete in days. And if you take about the loss due to friction, when I talk about the loss due to friction, it will be P naught into mu alpha plus K into X bar, where P naught is the initial stress and mu is the coefficient of friction. Alpha is the cumulative angle in radians, K is the wobbling, X bar is the length of the span, K is the wobbling constant. And apart from this, if they ask you what is the loss due to anchorage slip, the loss due to anchorage slip is given by the formula ES into delta L by L. So this is the loss due to the anchorage slip. So I hope you have enjoyed this session, and remember, my dear students, try to share this session. It will really helpful. We are not only conducting this session for civil engineering, we are conducting for all the branches, and we have an extraordinary team for mechanical, which is by Dr. Vijay Kumar sir. He will be teaching production, and we have Prajna Tripathi sir for thermal engineering, and we also have an extraordinary team for civil engineering. My colleague Pratik Mishra, which is led by me, and Pratik Mishra is one of my colleague, and Ankit Dongrial, who will be teaching the foundation engineering and also the structural analysis part also. So my dear students, if you are really helpful, if these sessions will, we are made these sessions to make a short notes and to make the life easy for you. So whenever you feel these sessions are prominent, or if you feel these are good for you, please try to share the session to as much people as you can. The main motto is, when you share this session to the right people or for the right gate aspirants, our intention is these sessions will be helpful for that. And at IMS GATE Academy, we have a wonderful team for civil and mechanical. For any queries, you can visit our Jayanagar branch. We are at sitting at Southern Circle. We can proudly say that we are the only center in Bangalore where we are providing the offline coaching for the with almost for civil engineering 900 hours plus. We provide the online coaching, we provide hybrid classrooms at Vijayawada. So my dear students, when you are thinking about IMS GATE Academy will be really helpful, because in IMS GATE Academy, we have a very wonderful future, that is one-to-one mentorship. Suppose if you are facing any doubts, how you have to prepare, and after the gate preparation also, which colleges you have to opt, all these things can be done easily through IMS GATE Academy, as we can interact with the student in one-to-one basis. I hope this session will be helpful for you, and thank you one and all for watching this session, and I hope this session will be sharing to all your friends. Thank you, and have a nice day. Good night. And tomorrow I will be on January 8th, I'll be starting the same session, quick revision through formula session from the geomatics subject. Geomatics is another important subject where you will be getting 4 marks. So thank you one and all. I hope these sessions will be helpful, and all the best for GATE 23. Thank you one and all.